Hey Calculus, we are starting chapter 7. We are going to learn differential equations. Okay, the first step, number 1, we are going to separate the variables. Okay, the official name for these types of equations are called separable differential equations. What does separate the variables mean? That means get all the x's and dx's on the right, and we want to get all the y and dy terms on the left. Okay, so let's move over and do that first step in example number 1. All right, we have dy over dx on the left. We have 2x over 3y on the right. All right, so this term, I'm going to highlight it. This term here has a y, that's a dy, so that's going to stay on the left. But this term here has a y in it. We need to move that to the left-hand side. So how can we do that? We can multiply both sides by 3y. So we're going to multiply this side by 3y, and we're going to multiply this side by 3y. I'm going to squeeze it in up there. Okay, so what happens? On the left, we have 3y dy. On the bottom, there's still dx. On the right, these cancel out, and we're left with 2x. Okay, so now the only thing that's left to move, I'm going to highlight it in yellow, is that dx. The dx has to move to the right. So what are we going to do? We're going to multiply both sides by dx. So I'm going to multiply the left-hand side by dx, and I'm going to put it over 1, and I'm going to multiply the right-hand side by dx. So now this is going to cancel here. On the left, I am left with 3y dy, and on the right, I'm left with 2x dx. So again, that's our first step. On the left should be all the y's and dy's, and on the right should all be the x's and dx's. Now, you obviously don't have to show this many steps. Some of you are going to get it with and be able to do it in your head. Some of you will need a couple steps, but you'll get there. But that's the first step. Now, the second step, I'm going to come back over here, is to integrate both sides. So what does that mean? That means we put a big elongated S on each side of the equation, and it looks like this. All right? So we're going to put an elongated S on the left side and an elongated S on the right side. Now we have two indefinite integrals. So we know that what that means. We take the antiderivatives. Antiderivatives. Okay, so on the left, this is going to be a power rule. Okay, 3 comes along for the ride. And y to the first, that's our power rule. That's going to become y to the second over 2. All right, then once we do the antiderivative, then we know that the notation drops out, and that's how we get rid of the notation. We get rid of the elongated S, and we get rid of the differential. All right, on the right-hand side, the 2 comes along for the ride. We're going to take the antiderivative of x. That's x to the first. That's a power rule. So that becomes 2x squared over 2. And, of course, plus c. Indefinite integrals get plus c. You only need plus c once, and we will always put plus c on the right-hand side with the x's. You will not need it on the left. Okay, so now we're just going to simplify it. Before we simplify it, let's talk about what our goal is. All right, our goal is to get the term with y in it by itself on the left. Okay, so we just get the term with y in it by itself. You don't have to get y absolutely by itself. So over here on the left, I'm just going to simplify that. I'm going to rewrite it as 3/2 y squared. That is the term with y in it. That's our goal. Get it by itself. It is. On the right, the 2's are going to cancel, and we have x squared plus c. And that is as far as you need to go for right now. Separable differential equations. Integrate or separate the variables, integrate both sides, get the term with y in it by itself. All right, let's go to problem number 2. Excuse me. All right, here we are. My iPad is glitchy. Hang with me, please, iPad. Come on. Okay. Okay, good. Okay, so the first thing we're going to do is we're going to separate the variables. So this dy stays on the left. This dx has to move to the right. So I'm going to multiply both sides by dx over 1. Dx over 1. So now on the left, these are going to cancel out, and I have dy. But on the right, when I multiply, I have e to the 2x dx on top, and on the bottom, I have 4y to the third. So now, I have to move this term over to the left because there's a y in it. This is in the denominator, so to move it over, I'm simply going to multiply both sides by 4y to the third. 4y to the third, and then 4y to the third. So now on the left, I have 4y to the third dy, and on the right, these guys cancel right here. This is over 1, and then you can see that these cancel, and I am left with this right here, e to the 2x dx. So that is my first step. Get all the terms with y in it. The y's and the dy's are on the left. The x's and dx's are on the right. All right, second step, we put a big elongated s in front of each side. We're going to integrate both sides. So we have two indefinite integrals. We simply find the antiderivative. So on the left, this 4 comes along for the ride. I need to take the antiderivative of y to the third. That's a power rule. So that becomes y to the fourth over 4. When I take the antiderivative, of course, the notation drops out. That's why we have that second step, so we can get rid of the notation. All right, on the right, this indefinite integral, to take the antiderivative of e to the 2x, that is a composite function. If you can't do it backwards in your head, that's going to be u substitution. So I'm going to go through that really quick over here if you need help with that. So e, we're going to go off to the side, e to the 2x dx. All right, 1. U is the inside function. That is 2x. That's the only inside function up there. Second step, we write the differential. The three things that we need, u becomes du. We take the derivative, which is 2. The derivative of 2x is 2, and we toss dx on the end. Now we go up and diagram. This right here is going to be where we put u. So this piece right here, that's going to get replaced with e to the u. Now what's left? Dx. That's what has to be by itself, so my adjustment is to divide by 2. So my new and improved differential is 1/2 du is equal to dx. All right. Okay, sorry, we're back. No worries. Fourth step, we rewrite everything. Again, this piece gets replaced with e to the u. Now, what am I going to replace dx with? Now I go to my differential, my new differential, dx right here. Dx is now equal to 1/2 du. 1/2 du. So, e to the 2x gets replaced with e to the u. Dx gets replaced with 1/2 du. Fifth step. The 1/2 comes along for the ride. The notation, of course, drops out because we're taking the antiderivative. The only thing that we need to take the antiderivative of is e to the u. The antiderivative e to the u is e to the u. And now, of course, we plug in u. So 1/2 e to the 2x. So now we march right back over here. The antiderivative of this is 1/2 e to the 2x, and on the x side we put plus c. Okay, you can simplify this right here, but we have the term with y in it all by itself. So y to the 4th is equal to 1/2 e to the 2x plus c. And there you have it. Final, best, full credit differential equation answer. All right, sorry it's late. I'm getting kind of weird. All right, bear with me. Number 3. Okay, now we got a little twist. There's no differentials here. Do you see any dx's and dy's? I don't. So now we have to make them appear. So check it out. Y prime, that's a symbol for derivative. We have to, oops, don't want to highlight it there, sorry. We have to rewrite y prime. Another way that we can rewrite y prime, we're going to rewrite that. So the y in front right here is going to come down, so that y stays, but I can rewrite y prime using Leibniz notation, dy over dx. So poof, now we have differentials. So when you see that y prime, you always want to rewrite y prime as dy dx. It's the same thing, it's just a different symbol, but it allows us to have differentials, the dy and the dx. Okay, so now we separate. Oh man, highlighter mode. I told you it's late. Okay, separate the variables. First step. All right, what needs to move over? Right here. This dx needs to move over to the right. That's in the denominator. So I am going to multiply both sides by dx over 1 and by dx. Okay, so on the left-hand side, of course, the dx's are going to cancel. I am left with y dy. And on the right, I just have x dx. We're set. They're separated. Second step, put an elongated s in front of each side. Yes, you have to show the notation. So now we integrate. All right, on the left, the antiderivative of y, that's a power rule. That is just going to be y squared over 2, power rule. And then on the right, same thing. The antiderivative of x is x to the 2nd over 2 plus c. It always goes on the right. So now I would just rewrite this. Pull out that coefficient right here, 1/2. So 1/2 y squared is equal to, same thing here, 1/2 x squared plus c. That is as far as you need to go. The term with y in it is all by itself. All right, one more, and we're going to call it a day. That's enough. Okay, so dy dx is equal to 0.5y. First step, separate the variable. So we want to move dx over to the right. So we are going to multiply both sides by dx. So I'm going to sneak it in there, dx over 1 dx. So these cancel. I've got dy by itself over there, but on the right I still have 0.5y dx. Okay, now I need to move this y right here. That's the only thing that I need to move. I do not have to move this coefficient. You can move it, but you don't have to. And in this case, it's easier to leave this here. So to move the y over to the left, I'm simply going to divide this side of the equation and this side of the equation by y. All right, so over here on the left, I have dy over y, and on the right, I have 0.5 dx. Okay, now I'm ready to integrate both sides. I've got the variables separated. So I'm going to put the elongated s here and the elongated s here. Okay, now let's look at the left-hand side. I don't know how to take the antiderivative of a fraction, but I can rewrite this so that I can. So there's still a 1 out front. I can pull out this, oops, that's not, I didn't mean to put a highlighter there, excuse me, there's a 1 here, I can pull out this fraction out front. So it looks like this. Oh man, highlighter, go away. Okay, so elongated s, 1 over y comes out front, 1 over y dy. All right, and on the right, I can just leave that alone, 0.5 dx. Okay, so now I know what to do with this. The antiderivative of 1 over y, hey, that's my flashcards. So that becomes ln absolute value of y. On the right, the only thing that I need to take the antiderivative is 0.5. The antiderivative of 0.5 is simply 0.5x plus c. That's a power rule. Okay, now we've got something new to learn. We need to get rid of ln. We have to get the y here by itself. So whenever you have ln out front, what we're going to do is we are going to exponentiate both sides. That's a big fancy word. See if I can spell it late at night. Exponentiate. Okay, what does that mean? Exponentiate both sides. That means that we are going to make e the base. All right, so we're going to make e the base. All right, so I'm going to put a big fat E here and a big fat E there. That's what exponentiate means. Make E the base. Okay, why do I do that? Because here the E and the ln are right next to each other. They cancel each other out. Brilliant. So now on the left, I am left with the absolute value of y. All right, on the right, my only goal, well, let me bring this down. I have e to the 0.5x plus c. Okay, now here's an issue. That c is in the exponent. We have to get this c out of the exponent. So what we're going to do is we're going to leave the left-hand side alone, but I'm going to rewrite this side. And I'm going to use exponents. Okay, so let me explain that. Let's go off to the side and review exponents. Remember when we have exponents, if we're multiplying two exponents that have the same base? Okay, so let's review. When you're multiplying two exponents that have the same base, you add. So that's equal to x to the 1 plus 3, which is equal to x to the 4th. So you have to remember that rule. So now using that rule, I'm going to rewrite this side like this. It's going to be e to the 0.5x times e to the c. So now you can see I'm multiplying two exponents that have the same base. This is equivalent to this. Why do I do that? Because this right here, I'm going to highlight it in red. This is representing our constant. Okay, plus c is a constant. All right, why does that still represent a constant? Because e is a number. E is 2.718. And if I take 2.718 and I raise it to some constant, I still have a constant. So that's why we did that. All right, so now we are ready to just wrap this up. You can either leave this as absolute value of y, or you can, the absolute value of y is just y. We can also sometimes put this out front because that's a constant. So what you can do is you can just call that c. That's the same as c. So we can put that out front. So we have c times e to the 0.5x. All right, and that is as far as you need to go. Okay, that is enough for today. About 20 minutes worth. We will do the backside of this note sheet tomorrow. All right, thanks, calculus. Fourth step. Ooh, hello.